Hello, and welcome to PodRocket, a web development podcast brought to you by LogRocket. I'm Noel, and today I'm joined by Will Madden, here to talk about Prisma Next and everything going on there. How's it going, Will?
Good, thanks. I'm really happy to be here, Noel.
So last time you were on the podcast, you were talking about Prisma 7. What's what's been going on since then?
I guess to put it in context, at Prisma, we have been on this journey of trying to migrate away from Rust for some time. And there's a few different reasons we want to do that. But one of the big ones is we want to be more flexible and be able to deliver more features faster. If you're a Prisma user or you're even on the sidelines watching, you've probably seen there's been a lot of frustration for a long time because there are features people want Prisma to support or database primitives they want to access through the ORM, but they can't, or like a whole new database they want to be using and they can't, or they want to use Prisma in a specific environment, but it doesn't work there. And we've been working our hardest to try and give users the things that they need. Like a lot of us used to be application developers as well. We feel this pain and we want to do these things, but we're a small team and it's a big code base and it has to work in a lot of different databases and environments and stuff.
Yeah.
So it's been really difficult to make that happen. So Prisma 7 was a really big step in the right direction. We did this big refactor away from Rust. So we took our core logic that was written in Rust, we cross-compiled it to WebAssembly, and we shipped that to users in their application bundles. And that meant Prisma could run faster, lighter, without the complication of downloading Rust binaries in the background and trying not to get in users' way, so you had to actually be aware of them.
Yeah.
There were a lot of advantages, and that's where you were talking to me last time. Prisma 7 had just shipped. That was the core component of it. Or Prisma 7 was just about to ship, I think, last time we were talking.
Yeah. Mm-hmm.
And this time, we're doing something even more ambitious. Since then, Prisma 7 went out. We had to make a bunch of compromises to get it out in the timeline that we had in mind. So it shipped without a lot of performance optimizations we wanted to bring, which we've since made. So it's now as fast or faster than Prisma 6. It was missing some core features, and we've filled in a lot of those gaps. One of the big omissions was Mongo support. Mongo's not a SQL database. So we were able to port all of the core logic for the SQL databases over, but not the non-SQL databases. And our intention was to come back and extend it, but that was really difficult. So between launching Prisma 7 at the end of last year and now, we've done a lot of that work. But at the same time, we had to ask ourselves, is this incremental migration from Rust to TypeScript, is it worth the effort? And Prisma Next started as a prototype where we were trying to answer that question and the question of what do ORMs actually mean in 2026?
Yeah. Did you guys kind of change courses much kind of as you were early in that journey and trying different things, or was it largely kind of led by this, notion of trying to get NoSQL supported?
NoSQL? No TypeScript. Sorry, no Rust.
Yeah. Gotcha. I mean, just like you said, like catching up. You said catching up the the compatibility for Mongo like databases was kind of one thing you've been working on in tandem. Like, how are you deciding where to focus your efforts?
Well, this has been a long, ongoing conversation internally.
Yeah.
Where one of the things holding us back was this monolithic core. It's really hard to change anything, and we couldn't accept any external help because nobody could actually understand the code base.
I see.
So losing support for Mongo was a symptom. It wasn't the root cause. It wasn't the root problem.
I see.
It was a symptom of how complicated stuff had become.
Gotcha.
And that was through, not because of negligence on our part that it became so complex. It was an architecture that was designed for a totally different operation paradigm that we had tried to bring along with us, but the weight of these legacy decisions had reached a tipping point where it was now more valuable to cut our losses and rebuild from scratch than to try and incrementally adapt the legacy architecture to where it needed to be today.
I see. Was there like much kind of, I don't know, pushback, or like what was the sentiment of the community? Like, did people kind of empathize with this and understand why you guys were doing what you were doing?
I think yes and no. Prisma's a like household name in the JavaScript ecosystem.
Yeah.
And we've bought a lot of goodwill over the years by giving people something that solves a core problem that they have and does it with a great DX and a smile on its face.
Yeah. Yeah.
Even if it can't always do what you want, it'll try and give you a really good experience while you're doing it. So I think we started with a lot of positive sentiment. And over the course of the last year, we've been really trying hard to be open and communicative and try to tell users, we think this is what you want. Here's our attempt to give it to you. What do you think? And then respond to the feedback we got. And I think that brought us a lot of positive sentiment as well. And we've been very open with the fact that we want to get to fully TypeScript, but I'm not sure people could really appreciate the steps that we took to get there, because they took so long. It was hard to see them as like one continuous set of coherent decisions to try and achieve one goal.
You also mentioned that kind of like part of this calculus was figuring out what an ORM is in the age of agentic coding in the AI era in general. What were the things you guys were kind of looking at and considering? How did that weigh into this kind of rework?
Well, I guess I can sum it up as one sort of mental exercise, which was the question that we posed ourselves. Agents are now a pretty typical part of most developers' workflows. And I can ask my agent to just write me SQL directly. So why do I need an ORM or a query builder? Like, why should I use Prisma or Drizzle or Keasley or any of the other equivalent tools when I can just have it write the SQL itself?
Yeah.
And the answer we came up with was, in the past, the value of an ORM was making your SQL queries read like your application logic so that you as a human could understand it, right? Like that's what they do. They shift your abstraction level up. So instead of speaking in the low level terms of your database, this table and that foreign key and these indexes, you get to speak in application terms. I want my users and I want the posts belonging to these users and I want the comments on those posts. If I can just speak in that high level of abstraction to my agent, then the value of translating your high level speech to low level database terms has just disappeared. So do we still need these tools?
Yeah.
And the answer we came back with after actually trying that with agents was, yes, they can write SQL. No, they can't write it correctly most of the time. And what they really need is fast feedback loops. They need a way to try something, see if it works, and then adapt based on the feedback that they get. And the shorter you make those feedback loops, the more effective your agents become. And the other thing you need is to limit the damage that they can do. Right?
Sure.
So that's the other big component, verifications or guardrails.
I think that this like rapid feedback loop is a thing that kind of people are realizing across domains, and there's a ceiling to the efficiency that like agentic coding can provide. That is, how quickly can you get it feedback or give it the context it needs to understand what's going wrong. Why is Prisma's position unique in kind of providing a solution to that problem here?
I think it's unique now primarily because we've been thinking about it. I think as we go forwards, more and more tools will be optimizing towards feedback loops, verification steps, and guardrails.
I see.
I think this will be the paradigm of the future. Right now, what it means in practice is we've built frequent checks into just about every layer of the system. So anytime you interact with Prisma, what your agent's going to experience, or you as a human, you'll experience the same beneficial feedback loops.
Yeah.
What you're going to experience is, let's say you're writing a query. The first thing you do is you experience the type system. Your editor will offer you autocomplete suggestions, and the query structures that you experience, like they come with all this type information that says you can use these model fields and they have these potential filters you can apply to them. Your agent gets the same input, right? If you do something wrong, you'll get a type error that says, you can't use this thing in this place.
Yeah.
Your agent gets the same feedback. So that's the first layer, the type system.
Mm-hmm.
And this is the one that all of the other type-safe ORMs and query builders provide.
Yeah, and it was kind of there already, right? Like it was kind of like this was what it was like before. Yeah.
This was the promise for ages and ages. That's why any of us are using TypeScript.
Right. Yeah. Yeah. Yep.
But then after you've written your query, when you go to execute it, Prisma Next, it knows the structure of your schema because you tell us up front, this is my Prisma schema, this is what I want my models to look like. Make sure my database looks the same way. But then when you're writing your queries, your query builder will not let you use database elements that are not backed by your schema. So you can't write a query, even if you escape the type system. The query client won't let you construct a query that uses a table that doesn't exist or a column that doesn't exist or an operation that's not appropriate to that column type.
Oh, interesting.
So that's the second layer of checks.
Yeah.
Then once your query is constructed, before it gets executed, we pass it through our middleware layer. And the purpose of this layer is to implement checks. So we've built a couple of very simple middlewares. One of them is the query linter, we're calling it.
Okay.
And it works the same way as ESLint. It has a bunch of like pre-configured rules. You can switch them on or off, decide which ones are errors and which ones are warnings. And it receives all the middlewares. They just receive your incoming query as an abstract syntax tree.
Okay.
And they can traverse it and say, well, you're asking me to do a delete, but you didn't provide a where clause, which implies we're going to delete the whole table. I'm flagging that as an error. You can't do this kind of query.
I see.
So, every step that it passes through has these verifications and checks. And anytime you violate one of these steps, your agent gets structured errors that include where the problem occurred, why contextually it's an issue, and what it can do to fix it.
I'm curious because it feels like the AST, like I understand how you guys or how that could be built if there's no kind of dynamic query building happening. Is that possible with like Prisma? Like, could I go in and like build a query based on like variables and state? Is there any of that, or is this like?
Of course.
So is there like? I'm not talking about like parameters being passed into functions, but I'm like dynamically including a where clause, like something happens like that. How do you guys build that tree when you like are passing around? When you have the capacity to pass around like a not yet executed query.
Well, the query builder constructs it's called the abstract syntax tree. It's a data structure representing a query, and you can change it however you like. That's what the query builder is doing internally. If you want to build that dynamically, it's exactly the same operation. Nothing changes for you. The only thing that will materially change for you is if you're doing it dynamically, you lose a lot of the type safety. We can't tell you at compile time.
That's what I'm curious about.
For us to tell you.
Right. Yeah. So
what we can do is enforce it at runtime.
Yeah.
Okay. We won't be able to construct an invalid query.
I see. So are these middleware layers happening at runtime then?
Yes,
as well?
Middleware
I see. I misunderstood. I was thinking that was like at a like a kind of a compile, air quote, compile time step where it was doing this validation. So how does that manifest in the application if it winds up trying to perform a query and you hit one of these like, oh, this is a delete without a where clause? Like, how does that manifest?
Well, you treat it pretty similar to how you would use ESLint. In your development environment, you would configure it to throw a hard error, halt the application so that I fix it immediately.
Yeah,
in production, you'd probably want to pipe your warnings or errors coming from your linter to somewhere else, to your logger or your error monitoring system, something like that. Like you have queries coming in that are suspect for these reasons.
Yeah.
I'm going to try anyway, but you should probably look into this.
Yeah. Gotcha. Nice. Is there different like configuration kind of settings as to how you'd want to eject out of various, lint query verification failures, or is it either have it hard stop or just give you a warning?
Well, right now the project's in a pretty nascent state. We only just built this thing. It's not ready for prime time yet. Yeah. But it proves the concept. I can imagine configuring it in a really similar way to ESLint, where you can say which rules are errors under which conditions.
Gotcha. Have you found that using like kind of having the presence of these checks and the configuration there, like in the repos, does that inform kind of agents as well? Like, will that have you found that there's less of a propensity to go and like write queries that would end up violating them by virtue of having the configuration there, or like is that not really a bridge that the agents have been crossing in your guys' experience?
Um, Honestly, the linter rules that we have protect you against such egregious errors right now. Like we just built a
Yeah,
handful of really simple ones that
yeah.
they're not cropping up that often to begin with
I
anyway.
see, I
But
see.
they're good
Yeah.
safety checks that like you're definitely not deleting everything, right?
Yeah, right, right, right. This is always kind of tricky. Like I've been in this space a couple of, employments lifetimes ago. Like I was working on an ORM that we were building internally for the firm. And you're very much in the realm of trying to glean what users want without like getting in their way. And now I think that problem's even a little bit more challenging if you're playing defense against agents that are maybe not behaving well or doing what they probably want to be. I think I'm with you. It seems to make sense. There's probably some very high level kind of guardrails. Like you probably don't want to be deleting everything in the table when this happens. But like, are there other, I don't know, specific kind of behavioral patterns or like types of queries that you guys have considered as things which may be indicative of something being wrong, and like how do you apply that to such like diverse domains in which someone might be using an ORM?
I think your goal is to be able to quickly and easily write queries well, right?
Yeah.
And agents, like humans, will benefit from like reinforcement. So if we can inspire you through a couple of simple lint rules to start writing queries in a way that is already like set up for success, your agent's going to start copying the patterns that it sees,
Mm.
right? And the best query is no query.
Yeah.
So
Yeah.
while we have done some work on linting these queries, those are a guardrail. They're intended to be like your one of your final protections because you have written a pretty bad query to begin with. We're going to try and stop you from shooting yourself in the foot.
Yeah, sure.
But better is to give you a way of writing good queries. So you can reduce the amount of query code you write pretty significantly with Prisma Next because we've given you, for the first time, we're starting to actually give you tools to define your application's like domain vocabulary.
Okay.
If you've used Active Record before,
I have, yes. Yeah.
then you
Hmm.
probably remember scopes. So we've built something that's a very close equivalent to that for TypeScript.
I see.
When you set up Prisma Next, you can provide a collection class for one of your models, for each of your
Okay.
models.
Sure.
And on that class, you define functions which return where clauses. And you build
Mm.
them up using the same everyday model where clause building DSL. So it looks exactly like writing a regular query, but you're just constructing the where portion of it.
I see.
And that lets you have named methods that say on your posts collection, you
Mhm.
could have a popular method which returns only posts which have likes above a certain number, right?
Yeah, sure, sure.
Then anytime you use the Prisma client and you say db.posts, now you can say .popular. So
Cool.
instead of like protecting you from writing that query poorly, you write it once and then you can reuse that collection method everywhere. And you can
Nice.
even use it on relationships to other models. So you
This is
can
what I
say
was about
like,
to ask. What if I always pull this and like I'm virtually always joining it to something else? Can you do the same for that
yes, you
relationship?
can.
Yeah, yeah.
Anytime you access that kind of collection, you gain those kinds of methods. So you can say
Cool.
like users.find ID, whatever, .posts.popular, and
Yeah.
so on and so forth.
To what degree are you guys hoping that becomes the way in which they build query? Like, do you like this idea of kind of scoping being like the top level thing, or like to what extent are you pushing that versus building the whole query, like in each place you might potentially need it?
Um, Whoever wants to repeat writing a query? That's like
Sure.
saying,
Yeah.
do you
Yeah.
do you like using functions? Isn't it better to just write the code every time?
Yeah. But
But we're
I feel
not.
like
We're
one could
not.
also just like write a helper function, right? That's just like on the side that kind of does the thing, and they could call that everywhere, and that they'd be deduplicating in the same manner. Is there like, you know, I'm assuming you're recommending they don't do that and they do it the new way. Is there like kind of
No, no.
a
Prisma Next is very hands off. We don't
yeah,
tell you to do anything. We're
sure,
giving you these tools.
of course, yeah,
But if you prefer to use standalone functions, these new query, these new ORM queries that you construct, they're very, very flexible. So
cool,
if you want to, instead of having a collection class which has filter methods on it, when you're building a regular where clause in Prisma, the thing that it takes inside it is it's self-composable. You can rip that out into a reusable standalone function of your own, and you can compose those functions together. We also give you like logical operators, an AND function, an OR function, and so on. So you can compose your own standalone filter functions together however you please.
neat.
You can even pull the other parts of the query apart and compose those into your own functions as well.
Oh, cool, cool. I'm curious now because you've brought this up, and we're thinking about like composing these higher level entities. I feel like performance always creeps into my mind here, and now that you've got this kind of paradigm of having a middleware, like a linter layer that's putting some guardrails on, is there any performance checks like, oh, you're doing like a weird join here that there's like no good indices on, like this could be bad? Are there any kinds of those guardrails in place?
Yeah, totally. Like that's checking that there's an index for something you're querying is one of the first linter rules we wrote.
Oh yeah, cool. Yeah, yeah,
The other middleware that we created was a simple budget middleware, which the goal was to like prove the concept that you can estimate what the time cost or performance cost of an incoming query will be before you run it. And you
neat.
can, or by doing an explain query to the server ahead of time. And then you can, refuse to run a query that's going to be too expensive. Like it's
Yeah,
got really simple logic for this proof of concept, which is just you tell it up front, like what order of magnitude you expect each of your tables to be.
yeah.
And then if you do a like unbounded query, we'll say, well, that's going to be the whole table. If it's a small table, it's okay. If it's a big table, you're not allowed.
Neat,
So
neat. Yeah.
absolutely performance is a part of it.
I'm sure there's places out there where it gets better, but I think it's hard to catch those like n+1 problems when you're writing them, especially when there's like higher level abstractions and like composability. You're not really thinking about it. I guess a dev, you're just like, oh, I need this, and then I need this, and then I'll do this, and then eventually you're like, wait, why is this one, like if a user does this one thing on Tuesdays and all of a sudden like this one query becomes crazy expensive, like what's
And one
going
of the
on?
things that's really hard to debug is like if you've got some part of your application that's slow and you're looking at why is it slow, and you've got your logs of which SQL functions were sent to the database, it can be really hard to piece together where they originated from.
Mm,
So Prisma Next queries internally, when they're constructed by the ORM, they carry a grouping identifier that
okay.
lets us assign if you've done some complicated nested operation across several models, and to fulfill what you've asked, we had to execute a couple of queries in a row, and this is
Mm,
where your n+1 problems crept in.
yeah.
In your telemetry coming out of Prisma Next, there's something similar to like an hotel span ID that tells
Mm,
you all of these things were related to the same original request that you made to us,
neat.
and we can piece back together what it was.
How are you envisioning maybe that manifesting like in debugging tools, like performance analysis tools? How do you envision that being surfaced to developers when they're like looking at their production app trying to find pain points?
Well, a simple way that we could use this is, let's say you have a middleware and it's receiving incoming queries or query fragments,
Mm-hmm.
and you want to construct something similar to, I don't know, Datadog or Sentry or something that's aggregating the queries that you've done, wants to present to you a history of we did these things, they took this long. That middleware has all the information it needs to do it. It's got
Mm,
the original ORM queries attached to their ASTs. It's got
yeah.
grouping identifiers that say these things were associated with each other. It's got timing information because it knows the beginning and the end of each query. It knows how many rows came back from them, how often they're executed. So that one middleware would have all the information that you need to build like a pretty sophisticated tracing application. So you could plug it into any Prisma Next application and it would work the same way everywhere.
We're super kind of far down in the weeds here. Is there anything else like about Prisma Next that's like a fundamental shift in how like developers should approach it, especially for somebody that's been kind of out of the or hasn't used Prisma in a while?
A couple of fundamental changes. Like the biggest one is we built this thing to be extensible so that let's say you want to use PG Vector, you go and npm install the PG Vector package, you plug it into your config, and now your Prisma schema, you can use vector columns, and they understand they have length and they have certain kinds of like properties. Cool. And when you're performing your queries, now your query builder just automatically knows you can do like cosine distance similarity searches on the vector columns that your models possess. So you're still speaking in terms of your models, but now you can search for models that are similar to each other.
Nice. Neat.
That's a massive change for Prisma. And that's like really one of the defining reasons that we wanted to adopt this new, do this rewrite to enable that kind of extensibility. Are
there any other players in the space that have that membrane between the database and the ORM is kind of thin in this manner that you guys modeled this new I don't remember the term you used, but kind of like this modularity pattern where you can just like npm install something that's one of the database features that you're using under the hood?
I think composing the configuration of your system by installing packages and injecting them together in like runnable TypeScript or JavaScript, that's a common pattern. That's like ESBuild and ESLint and
you name it. Yeah.
Everyone does this, and it's a really sensible way of aggregating new behavior. But having database types that can pass through your system and augment your type system as well as your runtime system, that's not something that I've seen anybody else do.
You mentioned Postgres specific features there. How does that work kind of if one's using like a different DB provider? Is this composability, this modularity, is it like kind of per backend? Is that how that's put together?
The backends themselves are injected behavior. Prisma doesn't natively know about any database anymore. If you want to use Postgres, you have to first give it the Postgres package, and then you can give it the PG Vector package.
I see. Yeah. How does it?
We want to do the same thing for like MySQL and also for Mongo. Like the Mongo story is going to be so good. We're working with the Mongo team, and it's just at the design phase now. But back in the day, the Prisma ORM, when we added Mongo support, we had to build most of it out of SQL primitives. Like you've got models and they have relationships to each other, and that's great. You get to think in terms of your familiar schema. But under the hood, it's got to turn into communication with a database.
Right.
And it still thinks in relational terms. Now with Prisma Next, because the actual database target that you give it is a provided extension, we can build a Mongo native experience that uses Mongo database primitives instead of SQL primitives under the hood.
Oh, cool.
That means we can use their aggregations and their like client field level encryption and stuff.
Yeah.
Whatever
that provider exposes. Are you guys optimistic that the community will kind of be able to leverage this kind of composability, this extension model a little bit more than historically like was the norm with Prisma?
Absolutely. Whether you're talking about users using this composability for to extend their apps, yes, absolutely. Imagine like it's going to be so much easier to just go out and pick and choose the extensions you want to add into your application to suit your particular needs, or the middlewares that you want to add, or like being able to mix and match collection methods that are coming from some utility library. Like there's so many forms of extension users benefit from. And if you're an extension author, there are a whole range of different extension points in the system where you can come in and author something that's unique that you want to share, or even something that is specific to your organization that you just want to package up for shared components in your platform.
Yeah. Cool. Yeah, I'm trying to think of a good example, and it's always tricky because like it's like who knows what people are gonna build, or like have some other kind of data source that they're trying to like augment something with along with their database queries or something.
Well, I
I'm
can
sure
think
there'll
of a
be.
really simple example that crops up all the time, which
Yeah,
is
please.
imagine you're building an API for your web application and you have incoming requests, and some portion of the request body is a model, and you want to validate that you're receiving uh, a model structure in the correct type. Back in the day, there were generators you could plug into Prisma that would output like Zod validators,
Yeah,
something
yeah,
like that.
yeah, yeah.
Now we output a JSON representation of your whole database schema, including all of the tables, columns, what types they have, what models are available, how they map to tables, what their relationships are between each other. So you
Mm.
don't even need the generator. You can just take this and the type information we give you, and you can do this at runtime on the fly for any model users want.
That's a good example of this like kind of dynamic responsiveness to something that isn't implicitly part of the system, but
Mhm.
like would benefit from this kind of bridge of the models that exist in the world and your nice kind of type safe with all the checks and safeguards in place. Let's kind of bring this back then to the kind of this middleware linter layer, because I feel like you could take that example and be like, okay, and then I want to ensure that no queries are ever like doing something weird with this bespoke version of this thing that's only for my app. Is that pretty pluggable as well? Is it easy to write your own validation rules?
Yeah, totally. Like it's all TypeScript. You can pull it apart and look at how it works.
Yeah, yeah, you can do
These
whatever you want.
middlewares are super thin. There's
Yeah,
hardly any code in them. They just like
yeah,
receive a query, compare it to some expectations, and then throw an error if it's false.
yeah. Cool. Do you envision that there'll be kind of like a, I don't know, like a marketplace of those, or like those will often be kind of shared or brought in by people, or there'll be kind of, best practices, like pull these lint rules off the shelf if you want to,
That is
you know,
exactly where I would like to see this head,
yeah,
because
cool.
there's a lot of practices that are going to be common to every application that's querying a database. You're going
Hmm.
to not want to do the same kinds of mistakes. Prevent people from shooting themselves in the foot with the same foot guns, right?
Yeah. Hmm.
I'd love to have like ESLint standard packages of lint rules for Postgres and MySQL and Mongo.
Yeah.
And I would love it to be community maintained because
Yeah.
there are
Yeah.
people out there who know a lot more about this topic than I do. And I would
Hmm.
love to have them involved.
What's the kind of migration path? Like how if you're on Prisma 7 currently, what's that going to look like for users?
We're looking at a couple of options. It's early days yet. We haven't even stabilized the APIs you're migrating to. So
Okay. Yeah. Yeah. I know. I know. I'm jumping the gun a
it's
little.
early to say,
Yeah.
but there's sort of like two broad paths of migration that we're looking at. There's the I want to run both systems in parallel option, and that should be really easily achievable. Prisma 7 introduced this concept of driver adapters, which let you have your driver is just a function in JavaScript that gives you a connection to the database.
Okay.
Prisma Next has a really similar abstraction. So we'd like them to be able to use the same connection to a database. So you can talk to one system or you can talk to the other, and they will both speak to your database the same way.
Gotcha.
That means you can incrementally migrate queries from different parts of your app to the new interface.
Nice.
But that's operating under the assumption that you have to change all of your queries. And that's going to be a big job for a lot of users. And we don't want to make people do that if we don't have to. So the other option we're investigating is like an interop layer.
Mm.
You use Prisma Next, but you put in front of it a compatibility layer, and it will interpret any of your original Prisma query structures and turn them into Prisma Next queries. So you get
Mm.
all the benefits of linting and validations and checks that Prisma Next gives you, and improved performance. But and you get to keep all of your identical Prisma 7 query structures.
Nice.
I think you will still want to migrate to the new queries anyway because the new query
Yeah. Hmm.
DSL is so much more flexible and pleasant to
Right.
use. And
Yeah.
so I think
But
people want to do it anyway, but you don't want to have to do it all up front.
yeah, yeah. I'm sure. I'm sure there's projects out there where there's thousands of these written. It's like we just can't. Like they'll get addressed when we are doing a feature or something in that area of the code base. Got
Yeah.
that kind of thing. Yeah, I guess you said you're exploring both of these options. Like, do you think it'll be like one or the other, or are these both going to be things you guys are offering?
I would love to do both, honestly. Like the having both systems running in parallel, I think this is a very easily achievable goal. Building a compatibility layer that works effectively and doesn't have any like unexpected quirks, that's a bit more difficult because there's a lot of like hidden behavior in the original query interface.
Yeah, and it's one of those things where it's like you can get. It seems like it'd be challenging to get like complete coverage. There's probably going to be some like weird edge cases where they're going to be hard to detect ahead of time, and
Yeah.
like things failing in prod. You keep prefacing that like this is kind of in flight a little bit still. We don't know like where is the like what's the timeline looking like? What are you guys looking at?
Well, I shouldn't make commitments to deadlines.
Oh yeah, sorry, I didn't mean to put you. What do you think users will be
my very ambitious personal timeline
excited about and like eager to get their hands on when you were kind of apologizing
today
for like, we don't have support people like Mongo and stuff yet. Like, what do you think will be the thing that most
to let
makes it up
see what
to
we're
people?
doing? I think if you're using Prisma, what matters to you is you get to build your application, which is ultimately the thing you actually care about, right? You get to build your application in your application's own terminology. You don't have to think about SQL. You get to talk in terms of models and their relationships. And if that's what you care about, the thing that's going to make the biggest difference to you is how you can build up your own application's data layer using Prisma. It's not just a query builder. You construct your own collection methods. You can build your own utility methods for doing the same types of operations on Prisma. Even if you're doing them across different models, you can build your auth layer easily in terms of Prisma's, the domain model that you give to Prisma. That's what I think the biggest difference to users is going to be, that you have so much more space and so many more tools to build application-specific data logic now.
Yeah, nice. Very cool. Cool. Yeah, well, thank you for letting me pick your brain. Well, is there anything else you wanted to touch on quick? Leave listeners with?
I guess we would love to hear what you think of our direction.
Yeah.
Right now, the best way for you to do that is to join our Discord server and talk to the engineering team directly. We are here and we want to hear what you have to say.
Nice. We'll be sure to get a link to the show notes to the repo and the Discord server and everything, so people can go find stuff easily. Thank you for coming online and chatting with me, Will, and letting me it's answering all my questions and catching me up. It's been a pleasure.
My pleasure. Thanks for having me on the show.
Of course. Take it easy.